In this video, I want to revisit the arithmetic operations on fraction. In particular, I want to take a closer look at multiplication. I'm going to go into the terminal and I'm going to import frac2. I'm going to create two fractions, 1/2 and 2/3. As we've seen, we can actually multiply these two fractions times each other using the star operator. That's what we normally use for multiplication. The reason why I can do that is if I go over to the definition of the fraction class, I have this definition of this method double_mul. Okay, that makes sense. But look, if I'm thinking about fractions in general and not just some Python code that I'm writing, there are a lot of things that I can do with fractions. I should be able to take a fraction like p and multiply it times an integer. But I get an error here. That error is at line 127. Wait, I wrote this code. Oh, and I wrote this code because I said that the precondition is that the other thing that I'm multiplying by has to be a fraction. And why did I need that? Well, because I multiply two fractions by multiplying the numerators and the denominators. And if the other thing is not a fraction, it doesn't have a numerator and a denominator, so I don't actually know what to do. Okay, but in the case of integers, I do know what to do. I just have to do something different. So is there a way to support multiplication on integers? Well, indeed there is. I just have to rewrite this method. So I'm going to go over to another module. This module is called frac3. You will notice that I have another definition of the double_mul method. But look at this. If I look at the precondition is different. It says that other is a fraction or an int. What's going on here? Well, all of these double_ methods, they technically don't have a specification. I could make them do anything that I wanted them to do because all I'm doing is redefining the meaning of a symbol. So I could change the precondition. It doesn't just have to be a fraction. It could be a fraction and an int. Now, of course, since I'm doing different things in each case, I'm going to do some top-down design here. I'm going to look at the other. I'm going to see if it is an int or not. If it is an int, well, I'm going to have this method called multiply_int. So this is a helper method, right? I'm doing top-down design, and it's going to do the int times fraction multiplication. And otherwise, I have this helper method that is going to do the fraction times fraction multiplication. Because this is a helper, you'll notice that I have an underscore in front of this. I am hiding this. I do not want the general user to access these methods. Instead, I want them to always go through the multiplication operation. In addition, these are helper methods. These are not helper functions, so I need to make sure that I call them as a method with self in front of them. But otherwise, it's exactly the same thing as top-down design. If I have two fractions, I multiply them together in the usual way. And if I have an integer, well, I just multiply it times the top, and I keep the denominator the same. Let's go see these in practice. I'm going to go import frac3, and now I'm going to make frac3 versions of my two fractions. So a frac3 version of p and a frac3 version of q. I can multiply two fractions times each other, but I can also take p and I can multiply it times an integer. Okay, great. So let's go look at this in the Python tutor to see exactly what is happening. So what I'm going to do is you'll notice that I have a definition of my multiplication operation, and it has these two helpers, multiply fraction and multiply int. And let's go watch this in practice. So I'm going to define the class. I'm going to create my two fractions, 1/2 and 1/3, or 2/3. Now I'm going to multiply p times q. That's going to call this double_mul method. It's going to look at the other. The other is a fraction. So what it's going to do is it is going to call multiply fraction. Multiply fraction does the normal fraction multiplication. That's going to call a constructor to construct our new fraction. And now we're done. All right, so that was multiplying two fractions times each other. Now let's multiply a fraction times an int. That's once again, that's going to call the double_mul method. This time the other is a 5. It sees that that is an int. It's going to call the method multiply_int as a helper. That's going to do the multiplication. That's going to construct a new fraction. So we're going to construct the new fraction. That's our answer. And now we're done. Okay, great. So this makes sense. Oh, but wait a minute. Multiplication is commutative. So that means that I should also be able to not just say p times 5, I should be able to say 5 times p. Okay, so let's go a step forward. And that's an error. Let's go over to the terminal. 5 times p. That's also an error. It says unsupported operation for star, int, and fraction. What do you mean? I actually wrote a version of mul that supports ints and fractions. Well, okay. Remember that star is an overloaded operator. It does one thing for ints, it does another thing for strings. Actually, you can use it on strings. And it does another thing on fractions. So how does Python know which version to use? The answer is it looks at the type of the expression on the left. So in this case, if I say 5 times p, it's going to use the integer version of star. It doesn't know what to do. If I say p times 5, now it sees that the expression on the left is a fraction. So it's going to use the fraction version of star, and so that's actually going to work. Is there a way to get around this? I mean, I'd really like multiplication to be commutative. Technically, yes. And I'm going to show you, but be warned, this is a little dangerous. I'm going to go over to frac3, and I'm going to go scroll down, and you'll notice that I have this code that it says uncomment this. I'm going to go uncomment all of this. I'm going to save the file. And now what I'm going to do is I'm going to quit and restart Python. I'm going to import frac3. I'm going to create my two fractions, once again, p and q. I can multiply them like this. I can multiply p times 5, but I can also do 5 times p. What's going on here? I have defined a new double underscore method. This double underscore is called rmul. This stands for multiply on the right. And I just say, okay, since I want multiplication to be commutative, I'll just have it do exactly the same thing that mul does. Why is this dangerous? Well, look, everything behaved very nicely when we told you that what Python does is it looks at the type of the expression on the left. Now what's happening is that you're muddying the waters. And if you start defining double underscore methods like this, it is possible for you to confuse Python if you don't know what you're doing. So as a general rule, we like to behave sort of the safe rule of the operation should always be defined by the type on the left. What we can see here is that, all right, I mean, these double underscore methods are starting to be a little complex now. How do we make sense of all of these? Well, that's what we're going to talk about in the next video.